All right, so you just learned the steps and the rules for solving log equations, and we went through those types of problems already where you actually solved out the equations. So right now, just a quick review really quickly of what are the steps for log equations, and then we're going to go into a review question, and then we're going to go into more types of those. So we're going to make it the easy ones for you, make it a little bit easy for you. All right, so it is really bright on here, so let me bring this down. Sorry about that, guys. It's a little bright there, but there we go. All right, so if we're looking at our steps, we had that quick little chant thing that we did, condense, swoosh, solve, check. So we know the first step is condense it, and that's down to 1 log. So condense it down to 1 log. The second step is to swoosh, and that's what I like to call it, the swoosh. It makes it easier to say instead of just saying change to exponential form. So that's what we're talking about, is swoosh is change to the exponential form. All right. Then after we swoosh it, then we have to do something else, which is solve. Oh my, somebody is blowing me up. Looks like it. No, it's an email. All right, so we did that part. We solve for x and whatever variable actually, because the variable could be t or it could be y or something else. So we're going to solve for that variable. All right, and then the last step is condense, swoosh, solve, and let's do it in blue. Check. Checkmate. So, and we check this in the original equation. So you're always going to put in the original equation there. So condense, swoosh, solve, check. Condense, swoosh, solve, check. Condense, swoosh, solve, check. Condense, swoosh, solve, check. So, all right, so now we're going to review our log equation. So we're going to go back to the log equation type things we did. We're going to use these rules that we just wrote down up top, and we're going to solve it out. We're going to go for it. Let's go for this. So again, we're just review of what we did already. So we're going to kind of go through it a little quick so that way we can make sure we're good on it and everything. So again, we're going to solve this function here. Log x minus 3 base 4 plus log x plus 3 base 4 equals 2. All right, so we're going to follow those steps we said. So again, the first step is condense it. And as a refresher, also, right before we did the log equations, we did the notes of the properties of logs. So we had our product rule, which meant that we were going to, whenever we were multiplying our expressions here, we give the m a log, we give n a log, and we put addition in the middle. So just like that Oprah video that I've had you guys watch. You get a log, you get a log, everybody gets a log. So that m gets a log, the n gets a log, and put addition in the middle. That's your product rule. All right, for your quotient rule, it was dividing, because quotient means division. So just a refresher again of this, guys. Remember the n got a log, the n got a log, and we subtracted there. You get a log, you get a log, everybody gets a log. Right? And then the last part, it's a power rule. All right? So the power rule means we had an exponent, and then we moved that exponent to the front. And again, we're moving fast through this because this is old stuff. This stuff we already learned. We're just applying it now, just refreshing, pulling it back. So we have that. So now we're going to go ahead and look at the first step, which is condense. And here we're looking at using, since it's an addition sign in the middle, so we have a log, blah, 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 log, blah, 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 and addition sign in the middle. The one that has a log, blah, 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 log, blah, 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 is your product rule. So here, we're given this side, and we need to go backwards to this side, which is our condensing part. All right, so here, again, it's right product rule. So we're going to use the backwards product rule here. So we're going to bring it backwards. So here, condense it down, we get log x minus 3 base 4 times x plus 3 equals 2. It's log x minus 3, x plus 3, base 4 equals 2. All right, we condense it down. Boom. Yeah. All right, second step says we're going to swoosh it. Swoosh. In other words, change it to from log function to exponential function. Swoosh. So with that, remember we said remove that log, the 2 in front, and that way we can swoosh it around. All right, we start with our base number, and we take it around town. Take it around town. Perfect thrust. Swoosh. So just like SpongeBob. All right, so we did 4 squared equals x minus 3, x times 3. X plus 3, sorry. Ooh. X minus 3, x plus 3. All right. The third step said to solve. Solve. Right there says solve. Solve for it. Solve for x. All right. So in our notes, we had it where we one of the equations we actually had to multiply this out, and we actually had to factor and all good stuff. This one's going to be a little bit easier. All right. So 4 squared is 16. We have x minus 3, x plus 3 here. It's really quick. If we multiply that out using FOIL or box method, whichever one you learned, rainbow method, as somebody else calls it, we get x squared minus 9. Right? And then we're going to add 9 to both sides here. We'll get 25 equals x squared. It takes square root of both sides, which is very simple and very easy. You guys remember that, I know. So I give you plus or minus 5 equals x. And again, because there's x squared right here, it means you have 2 answers. And since you have 2 answers, that has to be plus or minus 5 right there. All right. Now, with that, before we actually go into the last part of checking, I'm going to go ahead and just really quickly go through that part there, because I know some people are just like, wait, Mr. Hall, like, wait, huh? How'd you get x squared minus 9? So let's do that really quick. I'm going to do the box method, not box method, some FOIL, or some people call it the rainbow method, same thing. All right, so we have x times x is x squared. Let me see green here. We'll do x times 3, which is 3x. We'll do negative 3 times x, which is negative 3x. And then we'll do, let's see what color did I use? This one. We'll do negative 3 and positive 3, which is negative 9. All right, so as we're doing it, this makes a rainbow. I get it. Rainbow colors. All right, so here we get the 3x, a positive 3x and negative 3x. We know those cancel each other out. So we're left with this x squared minus 9. And so here, that's what we did. So we multiplied it, worked it out here, and then we got it right back there. All right, so now the last part is to check it. Just make sure we have we know which one's the right answer, because they most likely both won't work. Because like we talked about before, sometimes it will work, sometimes they won't. And 9 times out of 10, they both will not work. But you got to make sure you check it, make sure you have it right. Remember, again, with this part, we're talking about checking, which means we have to check, in the original equation. And that's what we wrote down at the top when we said check the steps. So we're going to check in the original equation, which was this. So writing it down, we're going to get this bad boy done. All right, so we get that. All right, and we're going to check x equals 5 and x equals negative 5. And with this, remember, we don't do it both in the same problem. We just deal with the positive 5 first, then we deal with negative 5. So we do 2 separate ones. And be like, oh my gosh, that's so much work. Not really. Not really. All you're doing is just putting it in here. You did most of the hard work already. Now you're just checking your answer to make sure you have the right answer. This way, when you're on the test, you won't be like, Mr. Hall, I'm not really sure how I did on that test because I don't know if I got the right answer or not. This is the way you actually know you got the right answer. All right, so we get that. All right, so here when we simplify it down, we get 5 minus 3 is 2. We have 5 plus 3 is 8. That equals 2. And in the calculator here, we're going to use Desmos, and we're going to go ahead and put them in and see if 2 equals 2. All right, so again, we're going to put this in Desmos, so we have it right there. Remember, we're going to hit function. We're going to do the calculator here, and just really quickly pull it in front. We're going to pull that in. We're going to hit functions. Make sure you go to miscellaneous right here, and we're going to do that one there with the A, the subscript of A. We're going to put the numbers in. We're going to do function again, miscellaneous. Got this part here. Base 4, and we have 8. And look at that, we get answer of 2. So here we get that 2 equals 2. So far, x equals 5 is one of our answers. So far, that's good. All right, so let's check -5 real quick and then see how we do that. All right, so really quick, let's do green. All right, so we get this bad boy going on. Again, we're using that same original equation. All right, we're going to put in -5 here. All right, and sorry, we put x equals -5 there. So we put in -5 here. We're going to simplify it down. All right, so we get those two. And hopefully you guys remember one thing, because I'm going to do this really quick off to the side. I don't know if you can see it. Can't see. There you go. And actually, let me pull the decimals off so I can actually focus on that. There we go. So here, hopefully you guys remember this part, because really we don't have to use decimals for it, not for this portion of it. When we talked about the very beginning, when it came to your rules for your definition of a log function, we said that b had to be greater than 0. We said that x has to be greater than 0. Has to be greater than 0. If they're not greater than 0, you automatically stop there and say you cannot do this. All right, so looking at it, just really quick. So we know b right here is greater than 0. That's a positive 4. But x in that spot right there, that gave you a -8. What in the world? So that's not greater than 0. So you can automatically say right here, does not work. They do not equal. They don't equal. They don't work. It doesn't work. Now, with that, if you don't understand that part, you don't remember that part for some reason, let's go to Desmos real quick and let's talk about that part too, because Desmos actually will give us something too that is actually really interesting. All right, so again, we're going to put it in just like we did before. Put the 4. Oh, we've got something right there. It says undefined. Okay, let's keep going though. Let's keep going. Oh, wrong one. Oh no, that's right. -2. Oh, we got undefined again. Oh. Okay, hit enter. It's still undefined. Oh gosh. If it's undefined, it means it doesn't work. So therefore, just like we just said here on the notes, because that does not that x is not bigger than 0, it's not a positive number, that means it doesn't work. So there we go, guys. That's it. All right, so your final answer will be x equals 5. And that's it. Booyah, booyah. We got that. All right.